So now let's estimate the integral from 0 to 3 of x squared plus 3 dx using left-hand rectangles, right-hand rectangles. Let's start with those. Using left-hand rectangles. And then right-hand rectangles. So here's my picture, and I'm going to use 6, by the way. I didn't say that. 6. What happens if I take smaller and smaller and smaller ones? It's better and better and better. But I'm going to use 6 of them. So I'll use 6 left-hand rectangles. So you have to then take the distance, 0 to 3, and divide this up into 6 portions. I'm going for 6 equal pieces. So I'm going to take this pen and I'm going to draw straight up till I hit the graph. Now I got to kind of think. Actually, I have it partitioned a bit for you already. Here's my 6 partitions from 0 to 3. And if I'm doing left hand, I need to go up the left side, and when I get to the graph of the function, then I'm going to cut straight over and come down the right side. So here's my first left-hand rectangle. My second one, I'm going to go up the side of the first one till I hit the graph, and then cut over and come down at x equal 1. So there's the second one. The third one, I'm going to go up the right side of the second one till I hit the graph, cut over. Here's the third one. And then the fourth one, I'm going up the side of the third one till I hit the graph, and we'll cut over. The next one, here's number 5, and then here is number 6. I'm going to grab a little highlighter, and here I'm going to find the area of the 6 rectangles, each one, and then add them up. And that'll be my estimate for the integral. Now I'm going to need some more numbers here. I'm going to need to know the points where the rectangles touch the graph. So let's see. This one's easy. This point is 0, 3. This one here for x equals 1/2, 1/2, comma. If you plug 1/2 into x squared plus 3, you're going to get 13 over 4. You can check that out if you're not sure. The third left rectangle touches the graph at 1, comma, what's the y value? 4. The next one, which has x value 3/2, touches the graph at a y value of 21 over 4. When I get to x equals 2, the x value is 2, the y value is going to be 7. And when I get to 5/2, the y value is 37/4. Now, if you're not sure about that, you plug those x values into the function and confirm that those are the y values. I don't need this one for left hand, but maybe for some completeness here, when x is 3, what's y? 12. Okay, I don't need it for the left hand because, because I didn't get that high. Now, your book does this. Your book for 6 left-hand rectangles, they call this L sub 6. And they mean you are using 6 left-hand rectangles. Now, I use a little different notation. I like to call this one L number 1. And this is not consistent with the book. This one I call L number 2. This one I call L3. This one's L4, L5, L6. See, I'm using L6 to be that last rectangle. Your book uses L sub 6 to mean the sum of the 6 rectangles. So there's quite a difference there in notation. Now, let's see though. L number 1. What's the area of L number 1? 1/2 times 3. Really, I don't really want to know what it is. I want to know how you get it. And it's base times height. How about L number 2? It's 1/2 times 13/4. L number 3 is 1/2 times 4. L number 4 is 1/2 times 21. I'm just grabbing the y value where it touches. L number 5 is 1/2 times 7. And L number 6 is 1/2 times 37/4. So my estimate with 6 left-hand rectangles is going to be, and I'm going to write it down here. In fact, I'm going to write estimate. It's going to be 1/2 times 3 plus 1/2 times 13/4 plus 1/2 times 4 plus 1/2 times 21/4 plus 1/2 times 7 plus 1/2 times 37/4. Now the last time I worked this in a previous class, I just found each number and added them up, but I thought of something better. I'm going to factor out the 1/2. Look, I can do that, right? 1/2, then 3 plus 13/4 plus 4 plus 21/4 plus 7 plus 37/4, and the answer is 1/27/8, and the decimal 15.875.